Let's hop back over to our recursion. I wanted to give you a couple of examples here, just because we're about to hop into some really heavy recursion, so I wanted to make sure that I really hammered home that you got recursion done pretty well. So I'm actually going to have you do another exercise in recursion. So we did up here Fibonacci, right? Which the definition of Fibonacci is n minus 1 plus n minus 2 of the Fibonacci calls. Factorials are pretty similar, that if you have 5 exclamation point, which is how you write factorial, a factorial is defined by n times n minus 1 factorial. So the factorial of 5 is 5 times the factorial of 4, factorial, right? So what this actually ends up being is, if I have 5 factorial, let's see, 5 factorial is going to be equal to 5 times 4 times 3 times 2 times 1, right? Because 5 factorial is the 5 times 4 factorial, and the 4 factorial is this, right? And then 3 factorial is this. And then 2 factorial is this. Does that make sense? So again, this would actually be even easier to write as an iterative solution, but I want you to write this in a recursive solution, that it's the factorial of 5 is 5 times factorial of 4. And then the factorial of 1 is just defined to be 1. But let's pop over here to the test, talk about what's going in here. What's your base case? 1. Yep, good call. It's going to be 1, and that's just, you can return 1. Then on your return call, like whenever you're going to do the recursion, how many recursive calls are you going to have? Just 1, right? Whereas Fibonacci was, the Fibonacci of 5 is the Fibonacci of 4 plus the Fibonacci of 3. The factorial of 5 is 5 times the factorial of 4, right? So you actually only have 1 recursive call as opposed to Fibonacci where you had 2. So first thing, base case, if num is greater than 2, sorry, less than 2 rather, less than 2, return 1. Otherwise, we're just going to return num times factorial of num minus 1. Or n. I have n here. There we go. Whatever you called that there. Actually, let's go back to num, because I think that's clear. Well, maybe not. Anyway. So let's go ahead and try and run these tests. We'll click play here. Play. And then down here on recursion factorial, you'll see that we passed our test. So again, this would be 100 times faster if we wrote this in terms of a loop, not in terms of a recursive function, but then I find this pretty descriptive of what it is, right? It's number times factorial of n minus 1. But you still kind of have to get that like brain space of like, this is like the body of one part of the function, right? So this factorial function actually does more work than just the 2 lines inside of it, right? Because this is still going to run, you know, several essentially iterations of it, several levels of recursion. Cool. Any questions about factorials or recursion or anything like that? So the question is, it can get pretty hard to conceptualize what's happening in the middle of recursion, right? It's hard to keep all that stuff in your brain because our brains don't really think in recursive manners, right? We think very much in a linear, imperative way of thinking. So coming into this more I would say it's slightly more declarative. This slightly more abstract way of problem solving can be quite difficult. So what kind of tips and tricks do I have of working through it? One, just accept that it's kind of hard and that your brain is not built that way, right? So if it feels hard, that's because it just is hard, okay? That's the first thing. The second thing that I'll tell you is, I try, when I'm starting to write a recursive function, what's the base case? That's the first question that I ask myself. And where is the recursion happening? Typically at the end, not always. I try and get those kind of pieces down first, and that kind of like frames my brain in terms of like, okay, here's when I'm done, and here's when I recurse. That kind of like provides like a base level structure of what I'm expecting to get done in any level of recursion. The other thing that kind of helps me is when I'm writing this like factorial function here on line 15, it's kind of hard to accept that like that's going to return the right thing because I haven't necessarily completed writing that yet. But what you need to do is you need to think of like, okay, if I call factorial of n minus 1, I need to assume that what comes back from that is correct. So you need to, before you have finished writing the function, assume that it's going to give you back correct output. So kind of building that base level assumption into your coding helps me kind of move forward, because sometimes I get hung up as like, well, if I haven't written factorial yet, then how is factorial going to give me the right answer? And you kind of have to work backwards from like, okay, assume everything is correct. Now we need to go forward and actually make it correct. So I don't know, those are my 3 best shots of providing you some sort of structure to it. Sometimes it helps to get on a whiteboard and just kind of diagram out the calls, right? Like model it as a tree. That certainly helps as well. Certainly when I was in college, I had a huge whiteboard in my room and I would just diagram everything out. But you can do that with paper and things like that. That always helps as well. Anything you can do to make the abstract more concrete in your brain is just going to help.
Thank you.
Yeah.
That's great.
Yeah, no problem. Any other questions?
Yeah, I got a question. So based on your explanation, I guess it's a good idea to think about recursion as a promise-like value. Would that be a correct assumption?
Yeah, based on my explanation, it'd be correct to think of recursion as like a promise almost. I mean, promise in the sense of like you get to treat it like something good is going to come back from it. Yeah, definitely. It's not asynchronous, right?
In a sense, like future value, not asynchronicity.
Yeah, it's a future value for sure. But yeah, I just want to make sure that people aren't getting caught up that it's not asynchronous, right? So the question is here inside of this nested array, it's const current equals array. And then it's going to recurse and call it again. Well, because those are different contexts, it'll be fine.